Hi, everyone, and hope everyone is doing well. Welcome to the Mr. X Physical Sciences Grade 12 free class, and we are doing the topic momentum and impulse. It's going to be quite an exciting time that we're going to have a beautiful 2 hours as we learn the concept of momentum and impulse from scratch. But very importantly, while we're speaking about momentum and impulse, what's going to happen in February is that we're going to have the Mr. X paid classes where every single month I'll have 5 classes for maths, 5 classes for physical sciences, and each of those 5 classes is 250. So 250 per subject per month. And in that package of 250, you get 5 classes, and we're going to be doing them from 7 p.m. to 9 p.m. For an example, for maths, grade 11, because I do grade 11s and grade 12s. Grade 11 will be Mondays, but Tuesday will be maths grade 12. Wednesday, grade 11 physical sciences, while Thursday is grade 12 physical sciences, and each one of them is 250 per subject. So if you're interested, please do contact Mr. X. I'm starting on the 3rd of February with the grade 11s, and the 4th will be the grade 12s as we start. It's going to be an exciting time. You've seen what I've done for others. I've given them distinctions, I've given them high marks, and I'll tell you this, I'm still as motivated and still as willing, even better more this year to help you guys. Remember, in these classes, the class will be recorded live, and those that paid for the classes will have access to the recording, but it will be a locked system, so you only have access alone from there on. All right, having said that, let's begin. Let's start. Momentum and impulse. Now, when you speak about momentum in physics is defined, and this is very important because definitions are 2 marks or 0. Momentum is defined as the product. That's a very important statement. The product of the mass of an object and its velocity. In other words, when you multiply the mass that an object has and its velocity, then you've got momentum. We speak about linear momentum because linear momentum is momentum of an object moving in a straight line. If you think about it, say that there is a car, the car has mass, the car has velocity, the car is moving on a straight line, the car has linear momentum because it's the momentum of a body moving at a straight line. In physics, we denote momentum with the symbol P. So P stands for momentum. And as a formula, is the mass of an object and its velocity. In other words, P, momentum, is mass times velocity. Now, it's important to know the units of measurement. When you're dealing with mass, the mass of an object is always in kilograms. There could be questions whereby the mass is in grams. You would need to convert that grams or those grams into kilograms. Secondly, as well, velocity is measured in meters per second. It's possible that you could be given velocity in kilometers per hour. You would need, therefore, to convert it to meters per second, the standard units of measurement of velocity. Now, because momentum is a product of mass, which is measured in kilograms, and velocity, which is measured in meters per second, the unit of measurement for momentum therefore becomes kg meters per second. Kg for mass, meters per second for velocity, and that's very important. So in the final examination, you need to know that your definitions are 2 marks or 0. Either you get everything or you get nothing, and so forth and so on. Now, further on, since the formula says momentum, which is P, is equal to the mass of an object and its velocity, by extension, it would mean, therefore, that momentum is directly proportional to the mass of an object and its velocity. If an object has a greater mass, then it will have greater momentum. If an object moves at a high velocity, it will also have greater momentum. So mass and velocity directly proportionally affect momentum. In most of your questions, if not all of your questions for grade 12, the mass of the object is assumed to remain constant. So the mass is constant. So the only factor that would increase the momentum is a greater velocity. See, I put this diagram. This is a truck. It's got huge mass. The one on the right-hand side is a truck, but moving at a faster speed. So this would mean, therefore, its momentum will be high. For the purposes of your questions in the exam, the mass is usually constant, and the only factor that affects momentum would be velocity. Further on, momentum is a vector quantity. In physics, when you say a quantity is a vector, you are saying that quantity is described in terms of its magnitude and direction. So when I say vector, I must talk about the magnitude. Magnitude means the size, how big, the value, the amount, as well as direction. So momentum, when you write out its answer, for an example, you could say 20 kilogram meters per second west. Notice the following. The 20 is the value. The 20 is the amount. The 20 is the size, and rightly put, the 20 is the magnitude. Kilogram meters per second, those are the standard units for momentum. But because it's a vector quantity, we speak about its direction, which is west. And while we're at it, it's important to notice the direction of momentum. The direction of momentum: west, north, south, right, left. The direction of momentum is the same as the direction of the velocity of the object. This is my third point. The direction of momentum is the same as the direction of the velocity of the object. So when I say 20 kilogram meters per second to the west, it also automatically means it is the same direction that the object is moving. It's moving to the west with a momentum of 20 kilogram meters per second. So those are the basics that we start with. Fine. So momentum, a vector, momentum is direction affected by velocity, especially when the mass is constant, and also P is equal to mv. Just a couple of things to remember when dealing with calculations of momentum. Number one, always convert mass to kilograms. Chuck Norris, listen to me. Again, I say this. Always convert mass to kilograms, velocity to meters per second. Secondly, because this momentum is direction sensitive, when dealing with questions, always choose a direction as positive. So whatever question you may have, always choose a direction as positive. Say for an example, the object is moving to the right. Could be a car that is moving to the right. I would write in my answer to say take right as positive. So you can do whatever you want as long as you make it clear to the examiner which direction you are taking as positive. Take right as positive. Now, by saying take right as positive in this example, it would mean everything that moves left, everything that moves opposite to what you said is positive becomes negative. Look at this third statement. All movements in the opposite direction will then be negative. So if I say right is positive, then if there is another object moving to the left, then that object's movement is negative when it comes to my calculations. So that's why the plus and the minus signs are very, very important. And when you write your final answer, you must write it with a unit, which is a number, and a direction. Okay? Say for an example, your final answer is negative 20 kilogram meters per second. If after the calculation, that's what your calculator gives you. What it implies is the following. It implies that this object has a momentum of 20 kilogram meters per second left. Angithi I said take right as positive. That means everything negative is actually to the left. So that's very important when dealing with calculations that have to do with momentum. All right. I'm hoping people are okay. Just give me a heads up to say, are you okay? Are you learning? Are you fine? And we go further. I want to talk about change in momentum. I will provide these notes for you, so don't stress. You'll have these notes and the memo that also comes through with that. So I hope everyone's still okay and we are learning right there. There's a question that says, when the mass is less or greater, not constant, what I think you want to say what affects velocity and momentum? Okay, let me just put this as a disclaimer. For your grade 12, the mass is constant. The only factor that will affect momentum is velocity. The mass is constant for grade 12. And that's what we're going to be dealing with as we're going along. Let's talk about change in momentum. Let's do some physics. Let's work. Now, in physics, change is given by this symbol, something that looks like a triangle. So when I say this change in momentum, change in anything means that you have an initial of it and a final of it. Then the comparison of final and initial would give you the change. Let's give an example. Say I was weighing 60 kilograms last year, and now I'm weighing 70 kilograms. So initially I was 60, now I am 70. There's a change in my mass. And when you deal with change in my mass, you have to consider the final mass, which is 70, minus the initial mass, which is 60. And so I have changed my mass by 10 kilograms. So every time you speak about change in, you consider a before scenario, you consider an after scenario. And in the context of change in momentum, it's important to understand what actually changes momentum. What is the physics of momentum changing? Follow my line of thought. Here's an object. It's a ball and it's moving towards the wall. I can see the direction of the object is to the right. Now, when the object collides with the wall, so hear my English, there is collision. Collision between the ball and the wall. According to Newton's third law, action reaction, whenever a ball collides with the wall, there is a force that is exerted. The force that the ball exerts on the wall will be the same as the force that the wall exerts on the ball. Equal in magnitude, opposite in direction. So because of the collision between the ball and the wall, it gives rise to a force. Newton's third law. Now work with me. Let's keep thinking. So the collision between the wall and the ball causes a force to be exerted. According to Newton's second law, oh, listen to me, Chuck Norris. According to Newton's second law, when there's a force that is exerted, the force causes the object to accelerate. So the collision brings about a force, okay? The force causes the object to accelerate. Forces exerted on objects cause objects to accelerate. If you go to the topic and you think you're going to be doing this topic pretty soon, and you did it also in a bit of it in grade 11, the topic is vertical projectile motion. Acceleration is defined as the rate of change of velocity. Rate of change of velocity. Notice this. When the object collides with the wall, bringing about a force, Newton's third law, the force causes the object to accelerate, Newton's second law. The acceleration defined as the rate of change of velocity. The moment we consider a change in the velocity, it means, therefore, when the ball moved towards the wall, it had a velocity that will be different from the velocity when the ball moves away from the wall. In other words, the velocity before it collides with the wall and the velocity after it collides with the wall, or final velocity, there are two different velocities. There has been a change in the velocity. Why did velocity change? Because the object accelerated. Why did the object accelerate? Because there was a force exerted on the object. What brought about this force collision? So it's important to get the physics. One more time, a bit slower. Talk to us, say. Talk to us. Help us to understand this physics right here. Listen to me. I'm saying to you, where is the ball going? Towards the wall. What's going to happen between the ball and the wall? There's going to be a collision. A collision. And the collision, according to Newton's third law, gives or brings about a force. Sure, now we have a force. Danko. Now the force that is exerted, according to Newton's second law, will cause the object, the ball, to accelerate. Acceleration is defined as the rate means time, rate of change of velocity. So the concept is this: because of the collision between the ball and the wall, there is now going to be a change in the velocity. And the change in the velocity means the velocity of the ball before collision and the velocity of the ball after collision are not going to be the same. There is a change in the velocity. But at the same breath, I want you to hear this out. The mass of the ball before and after collision is the same. I said it to you. For your level, the mass is constant. What is changing is the velocity of the object. Therefore, when you do your maths, follow my lead. Angithi change in momentum is final momentum minus initial momentum. Yabona E, final momentum, is the mass of the object multiplied by the final velocity of the object. Initial momentum, mass of the object multiplied by the initial velocity of the object. So when you say final momentum, mvf, minus initial momentum, mvi, the m is the same. The mass of the object does not change. You can factor it out mathematically. So that's m, then bracket vf minus vi. Therefore, change in momentum is equal to the mass of an object multiplied by the change in the velocity. Listen to me. Let me conclude this slide. Do you want to change momentum? Yes. Make sure that there's a change in the velocity. But say, how do I get a change in the velocity? Make sure that there is a collision. Whenever there's a collision, there is a force that the wall exerts on the ball, that the ball exerts on the wall. That force brings about an acceleration. The acceleration changes the velocity of the object. So collisions bring about a change in velocity and consequently a change in the momentum. Do you want to change momentum? Yes, sir. Go deeper, sir. Then change velocity. Then allow the object to have a collision. And you see, what is interesting about this diagram is this. Work with me. The direction of the object even changed. It went right, boom. Then it went left, boom. After and before. This formula, the one at the bottom, the one in bold, change in momentum is mass of an object multiplied by change in velocity, is very important when you're dealing with this particular topic. Follow my lead. Let's keep on adding some more information. Look at this example here. Very simple example. Look at this. I've already put the answers for you as well. But let me read this question so that it becomes easier to understand right there. Follow my lead. It says a ball of mass 0.5 kg. That's the mass is already in kg. Good. Initially, remember the English, initially moves to the right at 6 meters per second and bounces against a vertical wall. The ball leaves the wall with the velocity of 4 meters per second as indicated in the sketch. I see that as well. Ignore the effects of gravity on the ball. Calculate the question, the change in the momentum. Now, the first thing is to always choose a direction as positive. Usually, we would say take to the right as positive. Sometimes we say take towards the wall as positive. So this is a statement, Chuck Norris, that you must write. Choose or take to the right as positive. So you write it down so that the examiner knows which direction you have actually concluded to be positive, to the right as positive. That would mean, therefore, this velocity of 6 meters is positive, while this velocity of 4 meters is negative because it's moving to the left. Change in momentum, this, you don't have to write all of this in the exam. You can just simply write it like this. Change in momentum is mvf minus vi. Follow my line of thinking. So the mass does not change, 0.5, but the final velocity, 4 meters per second, but it's negative. Why is it negative, say? Because it's moving to the left. So -4 minus from the equation, Chuck Norris, from the equation, minus, then what's the initial velocity? 6. The rest is maths. I got my answer as -5 kilogram meters per second. But when you conclude it, you would say the change in momentum is 5 kg meters per second to the left. The negative shows you the very direction that it is ultimately taking. So you can choose and say right is positive. You can say left is positive. As long as you are consistent, your answers will remain the same. So just to reiterate this question, it moves to the right. So who's positive? We chose right as positive. That's why the velocity is positive 6 meters per second. But the one way it is after the collision, it moves to the left. Even the diagram shows it. That means, therefore, it's -4 meters per second. Your VF, negative to the left. Then the minus is from the very equation. Then the 6 there, which is a positive, and your mathematics gives you this value. That's how you calculate the change in the momentum. Step by step, we learn, then we can do questions. So here are some points to note. The momentum of an object will change if the mass or the velocity, I've talked about this, of the object changes. the velocity changes most of the time, which is what I've told you right now. So the velocity will change most of the time. But I like the third point. That's why I put it there. It's possible that an object has zero momentum. Very possible. And it has zero momentum when its velocity is zero. In other words, when the object is stationary or at rest. So every time the object has zero momentum, it's because the object is at rest or is stationary. A car that is parked outside your house right now, it has mass, yes, but it is stationary, so its momentum is zero. So it's important to know under what conditions are we dealing with zero momentum. For your level, zero momentum is found when the velocity is zero, ultimately when the object is stationary or at rest. These words, stationary, these words, rest, are useful in questions because they give you an idea and an indication that whatever object you are dealing with is not moving. Velocity zero, momentum zero. Fine, listen to this. Just as a conclusion on the last statement. So this statement is an explanation of what I said before, Uti. Collision, then force, then acceleration, then change in momentum. Ultimately, I say to you, do you want to change momentum? Yes. And what do you do when you want to change momentum? Change velocity. But for you to change velocity, there must be a collision which brings about a force. And there's a beautiful conclusive statement, which is what you need to know as I get ready to tell you or to teach you about impulse. Here's my statement. Listen to this. And I'm going to read it slowly. A net force, angithi collision, net force, collision, net force. A net force, therefore, causes a change in the momentum of the object. A net force causes a change in the momentum of that particular object right there. So that's very important to remember. A net force causes a change in the momentum of an object. Somebody's asking a question. Let me just read it. So say if I chose the left as my positive and my answer is positive, would it be wrong? No, not at all. Correct. Everything is direction sensitive. That's why you are allowed to choose a direction as positive. Fine. Momentum done. Are we still okay, fam? Talk to me. Are we still understanding? Screen lapo, seba enterisha, and. Can you still hear me properly? Are we still good? Talk to me, people. Talk to me now. Okay, we're still good. Perfect. All right, let's move on. Let's go to Newton's second law in terms of momentum. So, part of your exam guidelines, part of the statement that is put across is that students must be able to define momentum according to Newton's second law. Let's build up a story. Newton's second law as a formula says to us the net force on an object is equal to the mass of the object and the acceleration of the object. So in other words, net force is equal to mass times acceleration. Earlier on, I said to you, acceleration is actually the rate of change of velocity. That's what I said. And if you combine the maths, it becomes m delta v, which is change in velocity, over delta t. But hold on, say, we've seen this guy before. We've seen m multiplied by delta v. M multiplied by delta V is actually the change in the momentum. So where there's M delta V, you just put change in momentum over delta T. So look at this. F net is now the rate of change of momentum of an object. So one more time, one more time, one more time. So what is net force according to Newton's second law? It is the mass of an object and its acceleration. But acceleration is actually change in the velocity over change in time. And so mathematically, it's now m delta v over delta t. But hold on, I have seen this somewhere before. Use says m change in velocity is change in momentum. So you can then replace and then write and say to yourself as a final answer, F net is equal to the rate of change. You see, every time you say over time, it means rate of change of momentum. So here's a new way of defining a resultant force in the concept of momentum. A resultant force, a net force, is equal or is defined as the rate of change of momentum. So in the exam, they will ask you, define net force in terms of momentum. And what will you say? And I'm reading it now. The net force or resultant force acting on an object is equal to the rate over time. The rate of change of momentum of the object in the direction of the net force. This will give you 2 marks in the exam. Please note this, fam. Please. Net force or resultant force is equal to the rate of change of momentum of the object in the direction of the net force. Perfect. I'm good to go. Let's move on to something else. Impulse. Remember, our topic is momentum and impulse. We've defined momentum and everything that goes along with momentum. Now, before I get to impulse, I need to make this clear. This formula, and we'll speak about it when I talk about motor vehicle safety, seat belts, airbags. This formula here is very important. F net delta P over delta T. Super, super important. Keep that in mind. It's useful when we do questions. Impulse. What is impulse? Now, from what we gathered about momentum, we learned that we need a resultant force in order to bring about a change in the momentum of an object. So without a resultant force or a net force, we are unable to change momentum because a resultant force will ultimately lead to a change in the velocity and therefore a change in the momentum. Now, here's my second statement. So here's an object, all right, and the object has a force acting on it. Okay, this resultant force, this net force, causes a change in the momentum. Fine. But that net force must first change the velocity. And when the velocity is changing, the momentum must also change. So bring me a net force. And Mina, as the net force, I will change the velocity of the object. And when the velocity of the object is changing, then its momentum will also change. Now listen to this thing. The longer, now I'm putting a concept of time. The longer the net force acts on an object, if the net force acts on an object for a greater period of time, the net force will cause a greater change in the velocity and ultimately a greater change in the momentum. Ooh, say that again, say, Utini. Says the net force that acts on an object, the longer this net force acts on the object, the greater the change in its velocity, and similarly, or consequently, the greater the change in the momentum. Speak to us, say, speak to us. What you saying? I'm saying net force, do your thing, man. Change velocity, okay. Then momentum will change. But then I'm saying to you, if the net force acts on an object over a longer period of time, the longer this force acts on the object, it means there's going to be a greater change in the velocity and consequently a greater change in the momentum of the object. So the longer this force acts on an object, the greater the change in the velocity, and thus the greater the change in the momentum of the object. This statement, this second statement, is the foundation of motor vehicle safety. The reason why we have seat belts, airbags, arrestor beds, and so forth and so on. This is because there is the concept that says if there is a net force acting on an object, that net force would increase the change in the velocity if it acts on the object for a longer period. So the longer this force acts on the object, the greater the change in the velocity of the object, and thus the greater the change in the momentum. I want to park my tent here. Listen to this, fam. Ooh, when you're describing stuff, this is the English. The longer, the longer, the longer this force acts on the object, the greater the change in the velocity will be, and thus the greater the change in the momentum of that particular object, so that it becomes easier to pull through from there on. So that's fine. That's all good and well. Fine. Then now we can define what impulse is. So Use says there's a concept of time, there's a concept of net force. And whenever the net force acts for a longer period, there's going to be a greater change in the velocity and similarly a greater change in the momentum. So then how then do we define impulse? What does this have to do with impulse? This whole concept of net force and time, what does it have to do with impulse? When you're defining impulse, impulse is defined as the product of the resultant net force acting on the object and the time the net force acts on the object. So the product of force and time gives a new guy impulse. And with that said, it would mean by extension that impulse is measured in newtons second. Newtons second. Newtons second. That's what impulse is. So the concept starts from the fact that when there is an object and there's a force acting on the object, the force that acts will change the velocity of the object and eventually the momentum. Impulse comes here and says, how long time? How long is this force acting? And if this force acts for a longer period of time, it will have a greater change in the velocity and ultimately a greater change in the momentum. Therefore, impulse becomes the product of the net force acting on an object and the time taken by that net force to act on the object. That's how you define impulse, and its units are newtons seconds. Newtons seconds. Those are the units of impulse. Fine. Good to go. I'm happy about that. Let's talk about a system. Let's talk about a system and break it down. Now let's go further because I'm about to do this is the second of last part, the system, conservation of momentum. Then you talk about motor vehicle safety. Then you go to the favorite part of the lesson, questions, 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 questions. Listen to this. Are we still okay? Talk to me, fam. Talk to me now. We're still okay, ne? I see that. All right, good. We're happy. Let's go. A system. When you speak about a system in physics, a system is a portion of the physical universe of Earth, whereby physics principles can be studied or analyzed. Listen to me. So right now, as we speak, cars are moving. Maybe a ball is dropping to the floor, or maybe, there could be a collision happening somewhere. Car A, car B, when they are moving towards each other, the physics that we can analyze about car A and car B. When I say physics, I'm saying the mass of car A, its velocity, its direction, its momentum. Similarly, the mass of car B, its velocity, its momentum, its direction. Those physics principles can be analyzed, can be studied, and that makes the whole car A, car B scenario a system. So it's as if we are at this moment, the whole world is ultimately looking at car A and car B and analyzing the physics of it. So a system is a portion of the physical universe that can be analyzed or studied. A portion of the physical universe that can be analyzed or studied. That's what a system is. Now follow my lead. Follow my lead. Listen to me and listen to me very carefully. So let's say, for an example, I'm throwing a ball towards the wall. So there is the ball wall system. Say someone is practicing shooting at a shooting range, and there is the bullet is moving out of the gun. So there is a bullet gun system. Say someone is jumping onto a trolley. There is the boy and trolley system, because we can study the physics of the boy trolley, car A, car B, gun bullet system. It's a portion of the physical universe that can be studied or analyzed. We can come up with physics principles from what is occurring between car A and car B. This is why I put across and said when car A collides with car B, we can analyze the physics that takes place between car A, car B, what? System, a portion of the physical universe that can be analyzed or studied. In other words, a system is a subset of a larger environment. Currently on Earth, there's so many things happening. This is Earth, so many things happening. Planes are flying, that's a system. Cars are colliding, that's a system. Someone is playing sport and hitting a baseball, that's a system. Someone is falling to the ground, that's a system. Someone is jumping up from the ground, that's a system. A system is a subset of the environment. That's what a system is. It exists in a larger environment. It's like a section of a larger environment, and you can use physics principles in order to be able to study that. Why am I even telling you this? is because the word or the phrase isolated system is very important when dealing with momentum. When we say a system is isolated, or rather we say sometimes a system is closed, and they want you to know this definition. An isolated or a closed system is a physical configuration of particles or objects that we study that does not allow the exchange of mass or energy to and from the surroundings. Okay, say, that's gibberish, man. Speak to us, speak English. I got your back, Chuck Norris. Look at this. This is a system. Let's say there's car A and there's car B. Then there's the environment. The system, when you look at it, it's not isolated. This is because the environment has an effect on the system, on what happens between car A and car B. The surroundings have an effect. But when you say it's isolated, you are saying there is no effect from the surroundings. In physics, we say an isolated system, the net external force acting on the system is zero. In other words, nothing outside is affecting what's happening between car A and car B. It's as if when you say it's isolated, you are saying the only thing currently happening is car A and car B moving. Everything else on earth is standing still. Everything else on earth does not affect this car A, car B system. Every time you assume that a system is isolated, a system is closed, this is because you are saying there is no external influence. That's English. In physics, the net external force acting on the system, the outside external force acting on the system is zero. And that means there is no energy transfer, there is no mass transfer to and from the surroundings. Hence, our definition here says an isolated or closed system is a physical configuration of particles and or objects that we study that does not allow the exchange of mass, no, or energy, no, to and from the surroundings. Isolated system. And that's very important that you pull through right there. Isolated system. So that's very important that you pull through on that. Now, why do we need to learn about isolated system and? This is because the principle of conservation of momentum is founded on the isolated system assumption. Listen to me. When you say something is conserved, it means what you have before and what you have after is the same. So if I conserve my 100 rands, it means I had 100 rands in the morning, I went to school, and I came back from school, and I still have my 100 rands. What I have before and what I have after is constant, is unchanging, it's conserved. The principle of conservation of momentum is applicable in an isolated or closed system. Your syllabus requires you to be able to define what a typical what the principle of conservation of momentum states. And for 2 marks, I took this from your exam guideline. For 2 marks, it says, the principle of conservation of momentum states that the total momentum in an isolated or closed system remains constant. That's what it says. It says the total momentum in an isolated or closed system remains constant. And this principle is very useful in solving problems to do with momentum. In fact, all momentum problems are solved by the principle of conservation of momentum. And that's how you write it for 2 marks in the exam. Look at this diagram in this example so you can see what's going on here. Follow my line of thinking. So you've got different objects. Object 1 with mass m1, this one. Object 2 with mass m2. So u1 represents initial velocity of object 1. U2 represents initial velocity of object 2. So look at this. U1, U2 are initial velocities. Usually we write them as VI or V1, VI initial or V1 initial. That's what people usually write. V1 initial, whatever the case could be. You could use any letter as long as it makes sense. But just for clarity, U1 means the initial velocity of object 1 when it's moving, and U2 means the initial velocity of object 2 when it's moving. Interestingly, object M1 is moving to the right, M2 is moving to the left, and they will collide. But before they collide, you can calculate their initial momentums. So look at this. The initial momentum Pi is mass 1, U1. Initial momentum of object 2, mass 2, U2. And then when they collide, now there's different velocities. V1, that's the final velocity of object 1, and V2, that's the final velocity of object 2. And they are moving in opposite directions. So now you've got final momentums for object 1 and final momentums for object 2. And the principle says the momentum that you have, the total momentum, in other words, the initial momentum combining the momentum of object 1 and object 2 will be equal to the final momentum combining the momentum of object 1 final and object 2 final. In other words, the sum, the total, the sum of the initial momentums before collision and the sum of the final momentums after the collision according to the principle of conservation of momentum is the same. It remains constant. And when you write it down as a formula, we usually write it like this. We say this. This is sigma from series in maths. It means sum of the momentum initial is equal to sum of the final momentum. That's basically what it says. Sum of the initial momentum is equal to sum of the final momentum right there. That's very, very important for us to understand that kind of situation. Now, you will see when I do some couple of questions with you, some past exam papers, how this concept comes in. I did put a couple of notes, but it's the same concept. I will show it to you via questions, how it's done and so forth and so on. Let's go to the last segment, which is impulse and motor vehicle safety. So I'm going to explain in detail. Then after that, we can do questions and apply what we need to learn. So far, I don't see any question, but if there's any question, please do let me know so that I can help you. But I'm also very happy that other people are also running through. Someone says, for the definition, does it not end with remains constant in magnitude and direction? Okay, so when you're defining the principle of conservation of momentum, yes, you can say remains conserved in magnitude and direction. You can. But the exam guideline just says remains constant. So you don't need to clarify further. What I've written in bold letters on this screen at the top The total momentum in an isolated or closed system remains constant. We'll give you 2 marks in the exam, and that's all that you need. So that'll be fine. Follow my lead, impulse, and motor vehicle safety. Now listen to my logic. Um, Safety in motor vehicles is a very scientific concept. When you speak about safety, you are talking about the concept of saving human life in the event of an accident, in the event of a collision. What scientific principles can we use that can ultimately avert or even reduce impact on humans? That's safety. So when scientists are thinking about cars and motor vehicle safety, we need to think on the concept of what actually kills humans during a car crash. Is the impact. So listen to my English as I build this up. Is the impact, right? It's the force that is occurring. Look at this car. This is a pillar. Let's say it's a wall, it's a pillar moving towards the wall. The impact or the force that the wall exerts on the car is the one that eventually can cause serious harm on humans. So then how do we then affect or reduce the impact of force that act on humans in a collision? Bear in mind, accidents are inevitable. Almost assuredly, they will occur. As long as there's humans moving, driving cars, accidents will happen. Mistakes happen, sometimes sadly so. So then how do we apply science to prevent or to reduce injuries on humans when it comes to accidents? So here's the concept. What happens in an accident or in a collision? So let's say I'm driving a car and driving at 240 kilometers per hour. Biri Marung is playing. I'm with my girl on the left-hand side. She's saying, baby, you're so hot. I'm like, yeah, girl, you're so right. And I'm singing the song, 240 boy nyabangena, 260 nyabangena. Nazo. And like, yo, Ziakala and girlfriend is saying, yo, baby, you are such an amazing guy. I love the way you drive. I'm like, girl, this is my thing, girl. I've been doing this since I was a teenager, hey. I'm good at this, hey. And I'm speaking funny like this. Script boys who speak funny languages. Yeah, yeah, girl. Yeah, yani. Yeah, yeah. I was cool Zulu. Yeah, yani. Oh, come on. Back to the example. Back to the example. All right. Listen to this. Um, so now suddenly there's a red robot. Yo, I need to now put on the brakes. Then I apply the brakes. Now, listen to this. Newton's first law says an object will continue moving or in a state of motion unless acted upon by a resultant or external force. So if I'm not having my seatbelt on because I'm too cool for the seatbelt, then when I apply the brakes and I'm moving at 240 kilometers per hour, science, according to Newton's first law, would make sure that I also fly out of that car at 240 kilometers per hour in the air. And when I'm outside, gravity says what goes up must come down. Gravity will drag me down straight to the ground, and that's a disaster. So the concept in motor vehicle safety is to ensure that when there is a collision and brakes are applied, there must be a force that must act opposite to the direction of me in order to try and stop me. Listen to me. I'm moving too fast. I need a force to stop me. Force is change velocity. When I say stop, it's English. But when I say change in velocity, that's physics. A resultant force is needed about to bring a change in the velocity of the object in me. I must move from 240 kilometers per hour into 0 kilometers per hour. So in other words, in collisions or crashes, an object needs to be brought to rest from a certain initial velocity. I must be brought to rest from 240 into 0. But who's supposed to do that? A force. And keep in mind, when my velocity is changing from 240 to 0, my momentum is also changing. Because when I change velocity, I must change momentum. But hold on to this. We need a force to do what? To act opposite to my direction. To do what? To change my velocity over a certain period of time in order for me to be brought to rest. So the safety features of a car, I'm talking seat belt, I'm talking airbag, I'm talking arrestor beds, I'm talking crumple zones. These safety features, they are designed in such a way that when an airbag pops out, when the seat belt moves me backwards, the airbag, the seat belt, is applying a force on me in a direction that is opposite to my displacement. If I'm moving forward, the seat belt applies a force trying to drag me backwards. If I'm moving forward, the airbag will pop out in a direction opposite to me, to my movement. So here's the point. Listen to me. An airbag can kill you. It can. But why does it not? Don't say because it's full of air. That air is under pressure and can literally kill you. Here's how it works. And the words I'm going to use are applicable in every scenario, whether you talk about airbags, seat belts, arrestor belts, whatever. Applicable everywhere. Listen to this. When we spoke about impulse, we said impulse is force and time. And I gave a statement earlier. I said, Yazim, the longer the force acts on the object, the greater the change in the velocity, and ultimately the greater the change in the momentum. But I want you to hear this out. Impulse is F times delta T. If the time of contact is increased, then the force of impact is decreased. So when you increase the time taken by a force to act on you, you have decreased the value or the magnitude of that force. I'm saying it again. Listen to me. What describing? If you increase time of contact, you decrease force of impact. The purpose of the airbag is to say it will pop up on your face. Oh, my word. Let me show you that diagram. Work with me. Work with me. Work with me. Look at this. I want to show you this. Look at this diagram on the bottom right. See? The collision. Boom. The person melts into that airbag. So the airbag is exerting a force on that particular person and is exerting the force over a long period of time. So the airbag extends the time of contact needed to bring about a change in the momentum of the object, of the driver or the passenger. One more time, listen to this. I need time. The key is time. Increase time of contact, reduce force of impact. The purpose of the airbag when it deflects is to say, Yazin Kolani, I am going to act on you. I need to stop you. But I'm going to act on you over a long period of time. So you are literally going to melt. Look at this. Look at this. It's melting onto the airbag. The time of contact is increased. And when the time of contact is increased, the force of impact is decreased. The key is time. Do you want to be safe? Yes. Extend the time of contact. And once you extend the time of contact, you decrease the force of impact. But listen to this. You know, the dashboard or the windscreen can stop you. But why does the dashboard or the windscreen hurt you? The reason is because the time of contact, when you hit onto the dashboard, your time of contact is limited, it's small. So once there is a decrease in the time, the force ultimately will increase. Remember, I told you the key is the Fnet time scenario. Did you decrease time of contact? I went to the dashboard. I bounced off the dashboard. I have increased the force of impact. So it's important, therefore, to understand this concept of safety, that the concept of safety is hinged on whatever mechanism you're going to use, whether it's airbags, seat belts, arrestor belts, whatever. Their mechanism is based on the fact that I would like to increase the time of contact. You see, with a seat belt, when the seat belt is on, okay, let me try and pull through. When the seat belt is on, when you move forward, if you look at this guy, this one here, this one here, let me just pull through on him because I need him to come through. The guy with the seatbelt, this one. Let me go back a bit. Hold on. The one on the back passenger seat. Yes. Okay, let me play it again. All right. This guy here, this one that I'm pointing at, this one, he's got a seatbelt on. So when he went forward, the seatbelt extended. And when it's extending, it's applying a force on this guy, but then it's extending over a longer period of time. And therefore, it's increasing the time of contact between the human and the seatbelt. And therefore, the force of impact, the force required to change the momentum becomes less. Why? Because the time has increased. If you increase time, you decrease the force of impact. Remember, the idea is to bring an object to rest. And to bring an object to rest, you must apply a force. And when you're applying that particular force, you are ensuring that the object is brought to rest, but over a long period of time. I love this explanation that I put down for you here. This on seat belts is the same video over and over again. But the point is, if the driver is wearing a seat belt, it will provide a net force in the opposite direction to the motion of the car. To avoid injury, this net force acts on the driver over what? Here's the key: a longer time, and its magnitude is reduced according to this equation. You see, net force and delta T. Without the seat belt, this net force will be provided by the windscreen or dashboard, which could result in serious injury or eventual death at the worst case scenario. Like this one here, no seat belt, too cool. Look at what stops him: the next chair, and that exerts on him, and it will affect him eventually. So it's important to bring about the concept of time and force. Once the time is increased, the time of contact is increased, then the force of impact, according to the equation, F net delta T, is going to therefore decrease. Now look at this. I want to go back. The explanation that I want, this part, hold on. I got your back. There we are. Increase time, decrease force. Increase time, decrease force. Increase time, decrease force. Tell your mother right now, she's there. Increase time, decrease force. Tell your father, he's there. Increase time, decrease force. Say it to yourself. Increase time, decrease force. And so the equation to base on, right now is this one that says impulse, F force, and time. Extend time of contact, of collision, then you decrease the force, right? and therefore it means you are hurt less or you are saved. And those are some of the safety features that are available. Follow my lead. Seatbelt, airbags, crumple zones. Crumple zones is the same thing. You see, the bonnet of a car, you see this part here, right? The part there and the part there. They're called crumple zones. So when there's a collision between two cars, let's say the cars collide, and then the force of impact before it gets to me, the driver, it will have to go through the crumple zone. So the time of contact between car B, which is hitting me, and my car would be increased. So when the time of contact is increased, therefore there is going to be a less force of impact. That's why car manufacturers, they design crumple zones so that the car has a greater chance of crumpling than rebounding. You see, if cars rebounded, the impact would be crazy because the time of contact in a rebound is less, but the force of impact is crazy big. Time is less, force is big. Just like in a relationship, when you go for a rebound, your time together is less, but the hit, the way they will break your heart with that rebound that you're trying to do. Chuck Norris, I tell you, you will write about it in the newspaper. Boom, like that. So crumpling increases time of contact and decreases force of impact. Nama rebound N. Why again? You're going to have a lot of force of impact because the time of contact is decreased. Crumple zones. Let me show you the next thing, the last one there. I think that's yes, arrestor beds. So when you guys start doing driving lessons, aboma learner's license and stuff like that, one of the symbols that you see this on the road. One of the symbols that you see is this. This symbol, this red, white, stands for what is called an arrestor bed. You'll find it a lot. We have it here in Jersey, in Krugerstop. I think when you're going to, there's a mall there. I think it's one of the malls there, close by. There's this arrestor bed. It's like a side patch of the road. It's a side patch of the road. It's usually put in areas where there's lots of trucks moving. So it's when the area that I'm talking about, there's a downhill. So the road goes down. It's like a mountain, goes down. And it could be possible that the truck can lose its brake or can't even brake on time. So then you put the arrestor bed. And what the arrestor bed does is it literally exerts a force. It's a patch of sand or gravel. I'll show you from the video now. It literally exerts a force on the wheels of the car over a longer period of time. And that force, as long as it's extended over a longer period, will decrease the velocity greatly, and eventually the car will come to a stop. So it's a side road specifically constructed to slow down and stop heavy vehicles that can encounter braking problems when descending or ascending on a steep slope. Look at this one here, quite interesting. All right, so basically that's the idea. So many parts of this video, but that's the idea. Whereby you're saying it's moving at a very high speed. You want a force to act on it over a longer period of time so that it can decrease greatly the velocity of that object. So you can see from the examples that I gave you from this video, it's designed to accommodate large trucks and it's called an arrestor bed. So listen to this. When a truck reaches an arrestor bed, the time interval over which the momentum is changed is increased. This decreases the force and causes the truck to slow down. I like this as an explanation. You see, one of the things I want to teach you is when you're answering questions, please speak physics. Don't speak English, Chuck Norris. Don't say the truck is moving very, very fast. So the sand is going to stop it so much. It's amazing. Don't speak English. Speak physics. Speak physics right there. So in physics, you say when a truck reaches an arrestor bed, the time taken over which the momentum is changed is increased, the time of contact. This decreases the force and causes the truck to slow down. Again, you can see the principle: time, force, time, force, increase time, decrease force. Let me see some of the questions there. What happens when many cars want to go there? Hey, Chuck Norris, that's going to be a disaster, hey? Usually it doesn't happen. Usually has one truck or two trucks, right? And all. So somebody says increase in friction slows down the trucks. No, it's not really the increase in friction, but the time of contact that the object has with the side road, with the arrestor beds, is what eventually changes the momentum and then slows the truck down. And eventually there's a safe stop of the truck right there. Now let's talk about collisions as the lastest thing. Two types of collisions: elastic and inelastic collisions. So in physics, there are two types of collisions: an elastic collision and an inelastic collision. When a collision is elastic, what it means is that the kinetic energy, and that for me is the key word. What it means is that the kinetic energy of the object before collision and the kinetic energy of the object after collision, they are equal. So if you were to think about an elastic collision, it's a collision where the kinetic energy before and the kinetic energy after are equal. So before we collide, I've got car A, I've got car B. The kinetic energy, the sum of the kinetic energy of car A and B before collision is the same as the sum of the kinetic energy of car A and B after collision. So what I have before and what I have after in terms of kinetic energy is the same. In other words, when a collision is elastic, you will see when I do part two of momentum, where I do more questions, high-end questions in the paid classes. This is just part one. In the paid class, I'll do part two, where I do only high-end questions. You'll see this is a very difficult question that I have. It works on the idea that you must know what an elastic collision is. That calculation is worth 8 marks. And the point is that if there is an elastic collision, the energy before, kinetic energy, and the energy after are the same. Remember from grade 10, grade 11, kinetic energy is half mv squared, mass of an object and its velocity. So whenever the collision is elastic, there is no loss in kinetic energy. What you had before and what you have after are equal. That is an elastic collision. What about if it's inelastic? Well, if it's inelastic, what it means is that the sum of the kinetic energies before collision is not the same as the sum of the kinetic energies after collision. What you have in terms of kinetic energy before collision and what you have in terms of kinetic energy after collision is not the same. But it must be noted that this basically is how the equation would look like. So if you want to prove that a collision is inelastic, then get the kinetic energies before collision and the ones after collision, and then from there on see which one therefore would have, or see that the numbers are different, and that would show you that it is inelastic. If the sum of the initial and final are the same, then it's elastic. But if they are all typically different, then it's inelastic. And this is what's happening. Listen to me. Look at these two cars at the bottom. Let me explain this concept quickly here. You see, this guy, the black car and the white car, before they collided, this black car had its own kinetic energy, so did the white car. You could have added their initial kinetic energies. When they collide, some of the kinetic energy is converted into heat when they collide and sound. You've heard cars colliding, they make a sound. Sound energy, heat energy, sometimes it's even light energy. Now, in that concept or in that scenario where there's a collision, the kinetic energy is not conserved. If you had 100 joules of kinetic energy after collision, you'd have 80 kinetic energy, and maybe the other 20 is your sound, your heat, or your light energy. But I need you to understand that the total energy remains the same. It was 100, and it, yes, but now the kinetic energy is 80 plus the 20. This is from the principle in grade 10 that says kinetic energy cannot be created or destroyed, or rather, energy cannot be created or destroyed, but can be changed from one form to another. So, this loss in kinetic energy could be due to the fact that heat was created, sound was made, light energy, and the damage was done. So, you don't have the same kinetic energy you had in the beginning that you now have after the collision. Oh, my word. Beautiful. So far, so good. Talk to me. Are we ready for the past exam papers, people? Are we good? Are we ready now to tackle the past exam papers? All right, let's do the last 30 minutes and do some questions together as a team. So far, so good. Did we understand? Right? All right. Yebo. Basho njalo abantu bathi yebo. Lapho. Bathini bona? Siyabonga. All right, let's work. Let's work. Work. Abanye bathi yebo, yebo, yebo. All right. Omunye uthi I'm so tired. Jack Norris. Hmm? If it was food, you wouldn't be tired, dang it. You'd be saying, give me more. Give me more. All right, let's go. Part exam papers. Here's a question from 2024, the Eastern Cape June paper 1. It is question number 5, and I'm going to do it with you. The next one I'm going to give you to you to try. But let me do this one with you just to see if you guys will understand this. As always, if there is a problem, you let me know and we take it up from there. Here's my story. A truck of mass 1,500 kilogram traveling at a constant speed of 20 meters per second to the west along a straight horizontal road collides with a stationary car of mass 900 kilograms, and the two vehicles moved together after the collision. The collision lasted for 0.2 seconds. And it says, ignore the effects of friction. In other words, when you hear this phrase that says, ignore the effects of friction, they are saying, assume that the system is isolated. So in questions, they give you the information, then they also give you the diagram. So from the information, the mass of the truck, 1,500, is moving at 20 meters per second to the west, and I can even see from the direction on the diagram. It's going to collide with the stationary car. I did say to you that when a car, object, or whatever is stationary or at rest, its initial velocity is 0. The mass of the car is 900. And when they collide, we hear this. The two vehicles moved together. Also, we are given information about the time taken for this collision. The collision lasted for 0.2 seconds. 5.1 says, explain what is meant by the term isolated system. Explain what is meant by the term isolated system. So your first questions are always your easy ones, and they're just basically definitions. So it is a system. That's what you would say. It's a system in which the net external force, I want you to write it down, is equal to zero. I also want you to write the title of the question where we took it from, 2024 Eastern Cape. So this is an isolated system. Sometimes they can say closed system, right? It's a system in which the net external force is equal to zero. That's 5.1 right there. 5.2. Calculate the principle of, or rather state the principle of conservation of linear momentum in words. So they want us to state the principle of conservation of linear momentum in words. So that's 2 marks as well. So we would say the total linear momentum in an isolated system remains constant. Remains constant. You can say is conserved, but I prefer that you say remains constant. Is conserved. You can say that. So 5.2, the principle of conservation of linear momentum. The total linear momentum in an isolated system, you can say closed system, but isolated is better, is conserved. 5.3, that's where the calculations come in. Let's get busy. I'm ready now. I'm reading. Calculate the speed of the vehicles after the collision. Speed of the vehicles after collision. This should actually be 4 marks, not even 2. It's about 4 marks. Even this one here should be 4 marks. It's fine. But let's work on it and pull through from there. So the question says, calculate the speed of the vehicles after collision. So here's how you get your marks, and I want to show you this. First of all, can we choose a direction as positive? So usually I would suggest that you choose the direction in which the cars are moving or the vehicles are moving as positive. And so you can see the truck is moving to the west. So I'll say west as positive. Okay, sharp. And we're looking for the velocity of the cars after the collision. Your first mark is to acknowledge the principle of conservation of momentum. This is what will give you 1 mark. 1 mark. So I know some of you guys were taught by your teachers to write mass of car, velocity of car initial, plus mass of truck, velocity of truck initial is equal to, remember they move together. So when they move together after collision, it's like a combination. So it's the mass of the car plus the mass of the truck multiplied by the velocity final, because they are moving together. If they are moving individually or if they rebound, then you're going to separate them. But here they move together. So some of you would write this. You don't get an extra mark for this, Chuck Norris. You don't. The only mark is this. Either you write this or you write that. Okay? The initial momentums and the final momentums. That's what you get. You don't get to write both these things and get 2 marks. You don't. Work with me. Follow my lead. So, in essence, at the end of the day, you're going to write and say mass of the car is 900. What's the velocity initial of the car? It's 0. You must show that, even though you know that the answer is 0. Mass of the truck, 1,500. And the velocity of the truck is a positive 20 meters per second. And it is moving to the west, and we said west is positive. Is equal to, they move together, combine their masses. Mass of the car, 900. Mass of the truck, 1,500, and you're looking for the final velocity of these cars after, or these vehicles after collision. I need they move together. They collide and move together. So we're looking for VF. Do the maths for me. I'll tell you this. I need a confirmation. Do you get 12.5 meters per second. Is that what you get for your speed? Talk to me as a confirmation. You're looking for the VF. Do you get 12.5? All right. So it's 12.5 meters per second. And that's basically the answer. They just asked for the speed of the truck or the vehicles after the collision. Write this down. It's worth about 4 marks. Let me show you the mark allocation. You'd have a mark for this statement, the first one. You'd have a mark for this part right here. You'd have a mark for this part. Then your fourth mark is that part there. So that's the speed of the truck. Now, there's a difference between saying speed and saying velocity. With velocity, you would need then to speak about direction. But with speed is a scalar quantity. You then just talk to it about the value on its own. So that's for speed. Somebody has a hand. Go ahead. I'm listening.
So, hi, sir.
Hi.
So, when we were doing the first when we first started the lesson, you said direction is important, and we put a negative for the velocity of the ball that was going the other way. So, why didn't we do it on this one?
It's because
Um,
both vehicles are moving in the same direction.
oh, okay. All
Yeah.
right.
So the direction is positive. That's why I said pick the direction in which the vehicles are moving as positive. So here we're saying they're moving to the west. So take to the west as positive. And so therefore, changing the momentum, or rather sum of the momentum initial and final. And so you need to get the momentum of this guy initially before the collision and this guy before the collision, add them, then get their momentums after collision. The key for me is that they move together. All right. So they moved together. So which means therefore, at the end of the day, you're going to have this velocity being for both of them since they move together. They're not separate. They move together. If they were separate, if the question said they were separate, then you have the mass of the car, the velocity of the car final, plus the mass of the truck and velocity of the truck final. If they said they move or separate from one another. So 12 meters per second, like I said, is speed, and speed is a vector, is a scalar quantity. You just need to get the value. I'm going for 5.32 now. They want the net force exerted by the truck on the car. The net force exerted by the truck on the car. Now listen to me. The truck is exerting a force on the car, but make no mistake, even the car is exerting the same equal force on the truck, though opposite in direction. I have a statement that I say to my students every time I teach. Your choice of the equation depends on the information given. What you choose as an equation to use in a question will ultimately depend on the information that has been given. So look at this. Net force exerted by the truck on the car. So that's what we're looking for. We're looking for net force. So we're looking for F net. But I've seen an equation like this. F net is change in momentum over time. I've seen that. Change in momentum being the mass of the object multiplied by the change in velocity. What are we looking for? The net force exerted by the truck on the car. So let's use the information that we know about the truck, right? Because it's exerting a force on the car. But I also want you to hear me out. Even if you use the information about the car, you still get the same answer. And I'll show you now. Let me use the truck. What's the mass? 1,500. What's the final velocity of the truck? 12.5. What is the initial velocity of the truck? 20. was the time taken. The collision lasted 0.2 seconds, and your answer is 5,000, or rather 56,250 newtons right there, and it's a negative number. So in other words, it's 56,250 newtons to the left. Look at the information that I used. I used the mass of the truck, the final velocity of the truck, the initial velocity of the truck, and the time taken. But since the truck is exerting a force on the car is also exerting a force on the truck. So even if you use the information about the truck, the car rather, you get the same answer. Let me prove it to you. Mass of the car is 900. Final velocity of the car is 12.5. Initial is 0. Remember, the car was stationary, so that's why the initial is 0. Then ultimately, at the end of the day, you're going to over 0.2. You're going to get 56,250 newtons. It's positive, so it's to the right. Notice something. You can say west or whatever. Doesn't matter. West or left or right or whatever. It's fine. Notice that the numbers, the values are the same, but the directions are different. And that's what Newton's third law teaches us. The car exerts a force on the truck, much as the truck exerts a force on the car. The forces exerted are equal in magnitude, though they are opposite in direction. Go ahead. I've asked to unmute you. Go ahead. All right. Just as a heads up, I know I said left. You can say east, west. Guys, it's not a rule that is hard and fast to say, oh, if you say left, you'll be wrong, blah, blah, blah. No, you won't. It's still okay to put it across. So you can say east here just to make your life easy. Then you can say west here just to make your life easy. But I'm just showing you how the memo or the stuff in the examination looks like so that you're not really shocked about what happens there. All right. So 12.5, remember, is the velocity of the car and the truck after collision. So each of them is moving at 12.5 meters per second. That's why the final velocity for them is the same. It's 12.5, they stick together. Truck 12.5, car 12.5 after the collision has happened. Let's try 5.4 and hear what 5.4 says. 5.4 says, is the collision elastic or inelastic? Then it says, use relevant calculations to explain your answer. Is the collision elastic or inelastic? And pull through from there. Now, before I do that, somebody's asking me to put the mark allocation. We would see where are the marks. Get a mark for the formula here, right? Get a mark for this substitution right there. And also this part here. Then you get a mark for the final answer. 1, 2, 3, 4. So it will be out of 4 eventually at the end of the day. So let's try 5.4. Is this elastic or inelastic? Remember, when it comes to elastic or inelastic, we need to consider the kinetic energies. So let's get the kinetic energies initially or before the collision. We work it out together. So kinetic energy as a formula is half mv squared. So initially it's half the mass of the car multiplied by the initial velocity of the car squared, which is 0, plus half the mass of the truck multiplied by the final velocity, or rather the initial velocity, which is a positive 20 squared as well. And when you get your numbers, you should get something like 300,000 joules. So this is the kinetic energy initially. Let's get the final one. The question says they move together. So it's half the mass of the objects, but they move together. So it's 1,500 plus U 900, then V squared, their final velocity, which is 12.5 squared. So the answer is 187,500 joules. You can confirm these answers. Remember, they moved together. Therefore, the collision is not elastic because the kinetic energy initially is not the same as the kinetic energy final. Look at it, there's a decrease. I had 300,000. Now I've got 187,500, which means I lost some to either heat or sound. So the collision is inelastic. Inelastic. Talk to me, fam. Talk to me. Here's some of your questions. All right, perfect. So the collision is inelastic. It's a 4-mark question. So how would the marks look like? How would the marks look like? Let me help you. Let me help you. So I would suggest maybe just write this half mv squared as maybe your first thing. Maybe that would do well because I'll probably get a mark for that one. Then you get a mark for this part. You get a mark for this part. Then you get a mark for the conclusion. And that becomes your answer from there on. Go ahead. I'm listening. I'm trying to unmute you so I can hear your question. Yeah, go ahead.
Hi, sir. So may I please ask, where is the 1 over 2 coming from? Or it's just a part of the formula?
Half mv squared is part of the formula.
Oh, thank you.
That's the formula for kinetic energy. All right, perfect. That's good. That's your answer right there. Let me see some of the questions. Do we write if asked whether there's an increase or decrease? No, you just simply say it's inelastic. You just say that the kinetic energy before and after is not the same. Guys, the formula for kinetic energy, nylon, half mv squared, mass of an object, 900, velocity, 0, half m, mass of an object, velocity squared. Angithi, half mv squared. All right, perfect. This question goes further. There's an interesting part. I had to put this diagram here because I thought maybe some people will struggle to understand what is called bubble plastic. All right. Bubble plastic and all that. Let me see. Somebody has a hand. I want to go ahead. Make sure that where you are is quiet. I've asked to unmute you. Go ahead. I've asked to unmute you. Please say your question or rather type it because I'm not hearing anything. All right, let's go to the next part. I feel like this will be my last question, yes? And we just end it here now. Now, here's bubble plastic before I even read the question. So, bubble plastic, you guys see this every day. You have it in the, as kids, you know this. We loved popping this like pa, pa, pa. Do you guys remember that? Ne? Yeah. So, bubble plastic is used to package delicate equipment. When you buy a fridge, for an example, they wrap it around with bubble plastic. Lab equipment, which is very sensitive and very expensive, is wrapped around with bubble plastic. And there's a scientific reason to that. It's not decoration. The plastic has bubbles of air. That's why we could pop them up. Now, here's the question 5.5. Delicate equipment is usually packaged using bubble wrap for safety of the equipment. Explain how this process keeps the equipment safe. How the bubble plastic thing keeps the equipment safe. Now, listen to me very carefully. So, in cases whereby the equipment falls to the ground, the moment it hits the ground, the air bubbles are first in contact with the ground. And so the force that the ground exerts on the object is spread over a long period because the air bubbles must first pop out. There's that boom collision with the ground, and the force the ground exerts on that delicate equipment is exerted over a long period. And once the time of contact, come on now, I'm with you, right? Once the time of contact is increased, the force of impact is decreased. So the concept of bubble wrap, and I'm going to write a very concise answer now, but the concept of bubble wrap is for you to understand that it has a soft surface. Number one, it increases the time of contact during the collision and therefore decreases the net force exerted on the equipment. I'm still hinging on that concept of F net and time, right? That impulse thing. I'm still there. Increase time, I told you to tell your mother, decrease force. So what does bubble wrap do? Follow me, this is the answer. So the bubble wrap, it provides a soft surface, okay? Provides a soft surface, So what? Which increases, let me just say comma, which increases the time. See the explanation. This is worth 3 marks, by the way. The time of contact, which increases the time of contact of the collision, and decreases the net force exerted, on the equipment. So once you increase time, as always, you will decrease the force. So that's how you put an explanation for this. The same thing will apply with seat belts. So sometimes they ask you and say, with the aid of an equation, this is what they are looking for, this equation there, this one here. Yeah, that's what they'll be looking for. Okay, you just write the same explanation, and then you say, according to the equation, F net multiplied by delta T, an increase in the time will decrease the force of impact. That's how you explain airbags, seat belts, arrestor beds, blah, 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 and so forth and so on. All right, fam. I think I've got so many questions. This will be part 2. You see this, that, this. Oh, Ntwana. I've got so much to give. So, you see, all this I prepare in advance and very well. Listen, fam, thank you so much for coming to class. I appreciate you. It's been a tough time, but I appreciate everything. But I also want to just end it up with talking about the very important thing. Guys, if you think I'm fire in class like this, wait for me until we start in February when we do the paid classes. I will be on fire. We'll be following the annual teaching plan, doing all the topics that you need to know for PEM number 1, making sure that everyone and everything is done properly. The handouts are already done. I just need to add some more questions, some more sophisticated stuff, put more diagrams, but I've prepared for the whole year already. I'm ready, Mina. I'm ready. 250 per subject per month, 5 classes. Each of those classes is 2 hours long. On Monday next week, we're starting with grade 11 maths. Then on Tuesday, we're going for grade 12 maths. Wednesday, grade 11 physical sciences. Grade 12 physical science will be on Thursday. Mr. X got your back. Make sure that you contact me for all related issues there. Thank you so much. I'm going to stop the recording. The YouTube family, thank you so much also for your comments that you're going to put there. I appreciate everything right here. I love you guys and take care of yourself.